Okay. First of all, were there any questions related to solid cam profiling? Feel reasonably confident you can write some profile toolpaths? I'm going to show you a couple of other ideas. To kind of just prepare this part a little bit for you. Okay. Although I probably just ruined that one. Whoops. So we'll take this QB illegal it says. That's a little harsh. Jeez. I don't want the solid cam police showing up.
Only cares about you, Dr. Rose.
What's that?
Only cares about you.
The solid cam police. Oh no. Okay. I'm going to show you a little so you probably already thought about this, but nobody's cut yet. So, you know, when you go to machine parts, you want to think about orders of operation. You want to think about what you need to do first, what you need to do second, and so on. And the reason that matters is as you remove material, you're going to be changing the stiffness of the part, changing where you can clamp reasonably without smushing elements of your part or coming up with difficult fixturing regimes. So you want to before you do anything on a part, you want to look at it very carefully and decide what am I going to do first on this? What am I going to do second? How am I going to do this? If I was to do this part out of the boundaries of this class, I think what I would do is square this thing up to exactly the rectangular dimensions it needs to be here. I think I would put these end holes in here because it would be a little bit harder to clamp this thing down to put these holes in. I think I'd put these holes in also for the same reason. And then I don't know if you notice this feature on some of these parts, but there's this little 45-degree chamfer on the back side. I think it's on all your parts because that's where it kind of fits into the launcher, and the 45 degrees help it go down the launch rails. I definitely put that in first. But for the purposes of this class, you know, we're only working on 2 machines. We got 8 groups, got a limited amount of time to machine. These are fairly complex parts with a lot of different features and a lot of different setups. So we're going to bail on a few of the features. We're definitely going to bail on the 45, and there's these little notches on some of your parts that are in here. We're going to bail on those, and see something like this crazy little fillet here. We're going to bail on that. So for us, since we're all clamped down to the machines, I think you're going to want to start doing tool paths that you can do from this plane, which is going to be, you know, drilling whatever holes you have in here and making whatever pockets you have in here and cutting the outsides, that sort of thing. So, but again, always think about your order of operations. All right. I want to show you couple of different ideas for profiling. So let's say I wanted to cut this face here and this little floor, this ledge. All right, so I'd need to make a profile around it. Now, like I said, this little guy here kind of complicates things. If I was going to select this geometry, I'd run into this. So in this case, I probably need to select this geometry. So I'm going to go ahead and do that. I'm going to go to Operations and add a milling operation, a profile. I'm going to select this geometry and select this guy. Now, somebody, you see there's this gap, okay? Somebody, probably me, drew in this line to bridge that gap. So you need to do that if you want to get across gaps. Now, one of the other students said they selected and they said gap exceeds the gap maximum value. Please modify the gap maximum value. So solid cam will, down here, will guess at what, if you wanted to jump that gap or not. So if you said, hey, go ahead and jump gaps of much larger than that is, it might allow you to just jump that gap. And it asks, do you want to close the gap? You could say yes. And it may go across that. I've never used that. If you wanted to guarantee it, you'd need to draw in geometry. But let's just see if it does it. Oh, it didn't like me making this gap that big. I bet that's in my options in SolidCam. And it doesn't like that geometry. Well, we can play with that another day. If you wanted to force it to work, you have to draw in the geometry, which I did. So let's just select it. Hey. Reverse the direction. Arrow is going the wrong way. Okay, cool. Accept that chain. Now, would this be an issue here at all if I stop right here? Running my end mill by it and I stop right there. Is that a problem? It is a problem. So theoretically, the tool's right here. It's a circle, right? It's right here. So the perfect theoretical center of that tool had just stopped on that edge. But nothing's perfect. Okay? So to guarantee that you're going to get that edge and make it right, you need to go beyond that a bit. Okay? You do that in a lot of different ways. You could lead in, lead out a little bit. You could draw in some more geometry and force it around that corner or force it to go a little farther. But you really want to go a little farther. Okay? Okay. Alright, I'm going to get a new tool. So I had this one from before. I want to use an 1/8 inch end mill. I'm not going to select all the other data, but we could go through there and select that. Alright, now why did I select a small, here's that end mill, that's kind of cool. Why did I select an end mill that small? to go across here. Why would I select it this small?
For your end condition.
The what?
Are you talking about the end condition that you were just mentioning, how you would want it to go a little further?
Yeah, that'd be one reason. Yeah, actually that is the reason, but I was looking for a different explanation. It's the same reason, different explanation. If I use a much bigger tool than this, let's see if it'll do it. Let's do another one. Let's do like an inch one. Okay, if I use this honkin' inch end mill, when I come by my geometry like that, see what happens? I'm going to impact that wall before I finish my geometry. And even if I didn't, I'm going to leave this radius right here that's way too big. Okay? So in some cases you want to select different tools to try and make corners. So that's what I'm doing here. To make sure my level's right, SolidWorks or SolidCam guessed, but I'm just going to make sure that I'm going down to this floor, and it was right, but just wanted to make sure. And I'm just going to breeze through all this other stuff. You could do something with this, but I just wanted to show you the tool path, so I'm not going to do finish passes and all that stuff. Okay, here's my stock. And I'm going to go ahead and run this simulation. Okay. It ran it. That's not exactly what I wanted. Why?
You didn't select the outside line.
Yeah, I didn't get... No, so it did this face. That's what I wanted. But what's the problem here? Doesn't look like the finished part's supposed to look. This material here is supposed to be gone, right? So I ran that profile, but it left all this material. So I didn't want that. So there's a couple of ways to fix that. The first thing we could do, the first thing we can do is we can set roughing paths that step the tool over a little bit here, a little bit there, a little bit there, until we get to that face. Okay? And that's this clearance offset gig right here. We need a wall offset for that to work, and it needs to be bigger than this gap here. I don't know what that gap is. Let's say it's probably 0.2, or 2.2 should be more than enough, I would think. Maybe not. We'll see. And then this clearance offset, let's see if we can pick these things. Looks like it's about 1/8. And then this step over says how much can we step over at a time? Well, it's 1/8. Let's say we step over by 0.06 all the time, or 65. We'll recalculate that. And let's simulate that and see what happens. Nope, it didn't do it. Oh, it cleared it all out. That's goofball.
You have to press the save button.
No, I did. I hit save and calculate. It's forcing it back to 0. I'll have to figure out why that's doing that. So that is a way to do it. You can step over. I have to figure that out. What other way is there to do that? If I couldn't figure that out, what else could I do to guarantee that I chew out all that material in there?
Do another profile pattern on the outside edge.
Could do another profile pattern on the outside edge. Yep. What else? There's another way.
You change your original profile pattern.
To what?
First, and then you hit that sidewall that you can find, and then come back.
Yeah, I could do two. I could use a much bigger tool and then come back in with a smaller tool. Could do that too. I could also write a pocket. I could draw geometry out a little farther here and pocket that whole thing. So there's a whole bunch of ways to skin this cat. Just wanted to show you that. Okay. Now eventually you're going to have to drill some holes somewhere. And I think some of you have already run into this. But when you go to do that, you're going to have to move this whole part, which means we're going to have to put a different coordinate system in. So I want to show you putting in another coordinate system. So we'll go back to this coordinate system manager and open it. And I can go here and I can add a coordinate system. Right click add. I'll select a face just like I always do. I didn't like the way it selected that. Oh no, I did. It's okay. So it dropped in this. Here was my old coordinate system. It dropped in this new one over here, and we need to make sure it makes sense for drilling these holes. So the tool's going to come down in the z-axis. So our tool movement has to be along the z-axis. So you've got to make sure that this z-axis is pointing parallel to the way the tool is going to move, and it is. Also check your X and Y and make sure it's right for your setup. So normally if I put this in a vise like this, this would be X, but what if I wanted X to be this way? So you may have to turn the coordinate system. Alright, but there it is. I'm going to pick origin, and maybe I like it over here. XYZ looks okay, and I'm going to select it. See how it says MAC coordinate system 2. Okay, and it shows it up there. And there's that second one. Now when I go to add my drilling path, let's go actually write one. So I'll grab this geometry. Oops. Before I do that, look at this. Machine 1. I need machine 2. Okay, so make sure you select the right coordinate system once you've added your coordinate system in. Alright, now I'm going to select my geometry. One last thing I want to show you, I forgot to show the other group. I'm going to select just a circle or two. And we'll just breeze through this quickly. I'll just select a drill. Yeah, whatever. Any size, any depth, that's okay. And then we can simulate it. So there it's drilling, okay. What I want to show you is be careful with your coordinate system numbers. Let's see if we generate G-code, what coordinate system then that's going to be in. So I'm going to generate G-code for my drills. Look here. It went to G55. And it's because it's coordinate system 2. Which is here. Machine coordinate system number 2, which will be G55. If you wanted something else, you have to change it. So if we wanted G54, you'd have to put 1, which you already have 1, so You're going to have to change 1. So you make that one 3. Let's say you were so you can edit this one also and make him 2 now because the other one is 3. Okay, you got to be careful with that. So if you write these 2 toolpaths and for your part, and they're always going to be in the same work coordinate system, you're going to have a problem. You're going to have to switch to a different work coordinate system to do that. Okay? Or you can save two different files. You can save this as your first version and have that coordinate system, and then open up a new copy, make a different work coordinate system, and delete the other one for when you drill the holes in the side. Okay? Just wanted to show you different work coordinate systems. Questions there? Alright, let's move on to exploded views and animations. Okay, these are really useful for presentations. So for clarity, I've got these drawings that pass around, take a look at. These are heat exchangers that actually went on shuttle flights. They were designed and built by our BioServe Center. They're heat exchangers for plant growth chambers that grow plants up there. So these are kind of exploded views or integration views, and they're useful. Notice you don't have dimensions and callouts because this isn't for manufacturing. This is for integration. So it's to show how all these little piece parts go together and what all these little piece parts are. So you can see they exploded the view a little bit. They put little notes saying what part is which. And I believe that drawing goes hand in hand with this drawing. So you can cross-reference the note number to what that part really is, and a file and drawing number in a tabular form. So views and drawings like this can clarify your project for people quite a bit. So I want you to have some sort of an exploded view, and then we're going to do an animation, which you can drop in as a AVI or a movie or some sort of other file. I want to have you drop that into PowerPoint's presentations, because that can help clarify your project as well. So first, let's start with exploded views. So I'm going to show you an exploded view that we have already. So this is this little tab that we've almost never used. It's called the Configuration Manager. So this here is one configuration. You can add other configurations. In this case, we have a configuration called Exploded View 2. And when you open that up and go to Exploded View 4, you can explode it. So right click and explode it. And you can see the engineer wanted to show how some of these things went together. So for example, this bearing goes into this hole. These screws go through this bracket and screw into the servo motor, etc. You can also animate your exploded view or your collapsed view. So see them moving in there? And you see this animation controller. You can change, right now I'm set to reciprocate in playback mode, so it goes back and forth, collapses, explodes, collapses, explodes. You can set how fast it goes, how slow it goes, and then you can save it as an AVI or another file type, and you can drop this into PowerPoint presentations or something, or even just have it saved as a movie file so you can show people. So this is a powerful little tool. So let's go ahead and see how to make an exploded view. So I'm going to go back to something you guys are really familiar with now. Your happy little sheet metal box. You guys' boxes were pretty good, by the way, for first timers. Pretty impressed. Trudy has them now. She'll be handing them out to people that need them. Alright, so let's say I wanted to explode view this box. You want to go into your configuration manager up here, and we want to right click, add a configuration, and we're going to name it. I'm going to call it exploded view 1. Okay, there it is. Now if you look at your assembly tab, you're going to have a bunch of different options here. One of them is exploded view, so we'll click that. And then you have to start exploding it the way you want to explode it. So for this box, we're probably going to want to remove the screws first, because that's what you do in real life. Pull the top off the box, and then remove the PEM nuts from the inside. So that's what we'll do. So our first step is we'll grab these screws. 1, 2, 2, 3. And since all 3 of these screws are going to be pulled out the same way, I chose all of them. You could have just done one at a time, but all 3 of these are going to come out the same way. So I picked all 3. Notice this little coordinate system. If you look here, you can grab one of the axes and pull it in the direction you want to pull it. It makes the most sense to come back on this red axis. So I'm going to pull that out. This little ruler shows up, so you can kind of sort of snap to where you want to go. But if you wanted to give it a hard number, you can just type it in here. Notice all these 3 go purple and it shows up this chain. You need to hit done, and there's our first explosion step. We can flip this around and do the same thing. Let's do a new one. These 3 screws. In this case, it looks like I want to drag on this blue axis. So I'll drag him out, say 2.5 inches. Done. That's important to select done. Uh-oh. I missed a screw. So in group 1 I only have 2. I need to add. I may have to redo that chain. Forgot a screw. We just can't have that. Okay, now I selected done. Let's grab the box and pull him off, maybe 7 inches. And then we can go in and grab our PEM nuts. I'm going to pull them off by, say, 1 inch. And do my other ones. Also by 1 inch. and that's it. So there's my exploded view. If you accept that, you can open that exploded view and you can collapse, or you can animate the collapse. Brings up that controller and you can see this thing being put together and taken apart, which is very useful for people to understand how to integrate components. Okay, so there's exploded views. Questions there? Okay, if you noticed on that other one, she had these little lines, and sometimes that provides clarity as to how these components go in. So if you wanted to add those lines, you go to your exploded view and then you hit explode line sketch, and then you start adding components. So we'll take this screw to this hole and it's going to drop in that line. You can drag the lines different ways and you can make them jog and do all kinds of cool stuff with them, but that's a route line. There's one there. Now you need to be careful how you select faces and such on those route lines. If I was to add one, if you select something that doesn't make much sense, like let's say I do the outer diameter of this PEM nut to the face of this box, that doesn't make a lot of sense. So SolidWorks will try and come up with some crazy path. You see this crazy weird jogging path thing? So it's trying to understand what you mean, but you selected goofy things. So it'd be more sensical if you selected, let's say, this circle and that circle. That makes more sense. Okay? So those are route lines. You can add those route lines in or not, depending on what you want to show. Questions there? Alright, it's exploded views. You need to have one for your final project. What if you wanted to make a drawing of your exploded view, which is what they did there? Really simple. Just go to Make Drawing from Assembly. Click your regular template, just like always. And because you made an exploded view, a new option comes up. Isometric exploded, and you can just drag that in and drop it in there, and then you can mess around with it in its feature states. So because you made that exploded view, you can now drop in a new view in a drawing, and that's how they did those. And then you can put, so like I said, in these drawings you really don't care about tolerances or maybe material types or anything like that. What you more care about is maybe having a table that shows this part is this part number, this part is that part number, that sort of thing. That might be interesting to put in there. Kind of clarifies your designs. Okay.
That expanded view to show the screws with the female portion and then the nuts with the male portion?
Yeah. You should be able to do that by hiding components or suppressing components, and then you can drop that view in and it'll only show the components you wanted to show. Is that what the question was? No?
I'm saying more like to keep it simple for assembly, you make your male piece and that has the PEM nuts on it, and then you take your female piece and put it on top, and the screws stay with your female piece as it slides down on top.
Oh yeah. Yeah, you can do that. So in that configuration manager in that you would not have that chain that puts the screws in.
Would you chain it to the other?
Yeah, you can chain it to the other one and have it come down if you want. So you're saying PEM nut into the male and then male up into the female and then the screws in? Yeah, you could do it that way. Sure, you have to do your chains in that order. Sure. Other questions? Okay, animations. So you're going to be watching a tutorial on this, but we're going to do a little bit more advanced stuff than the tutorial. You may want to animate this somehow. You may want to make a movie out of this. You can do that down here in this motion study tabs down at the bottom. And you've got all these different kinds of options. You've got your exploded view 2. You've got orientation and camera views. You can look at this from different ways. You've got lights and camera and scene, so you can make the lights come from a different way. Notice there's a shadow down here, so the light must be coming from up the top, projecting a shadow down. You can change that. Here's all your features down here, so you can make movies and move these features, make them do things. So for example, you might want to say for a movie, just for clarity, you may just want to take this thing and spin it around like this so people can see the whole thing, right? Or maybe you want to flip it upside down and zoom in and show them this component like that. You can make a movie that does all that. Okay? You'll see that in the tutorial videos. They'll show you how to do those kind of videos. You also may want to do animations that show not just the parts and the assembly, but functionality. So if you remember this part, it's a camera with a laser rangefinder. In fact, actually, this is the laser. This is the laser ranger, and this is the camera. And it was supposed to be tracking an object and it's bolted to a 6 degree of freedom robot, and it's tracking the object, right? It does that through a 2-axis gimbal system. So this servo motor will tip this thing up and down, and this servo motor will twist it around in a circle. And then they wrote a software algorithm to track that object and drive those motors. Well, if you want to see how that works, before we do it, I'll show you. Here's the video. You can see that makes it very clear as to how this thing works. Much more clear than just looking at it, right? So it's a powerful tool to use. Alright, so let's say we want to do something like that. Now this is a super complicated one because there's a lot of components here, and she mated all these components together. And some of the mates prevent you from turning, right? So we have to find the mates that would prevent us from moving on these gimbals. And we also have to unfix some of these components. So for example, if you look at Piranha 301, that's this bracket. That's really what we want moving. It has a little F next to it, which means it's fixed. Okay, so first thing we need to do is unfix it. We'll float it, let's say in this configuration. I want to see if anything else is fixed. Doesn't look like it. We are going to have to fix this though, because if we start moving this piece, the other piece doesn't know that it's can't move. So I'm going to take this servo down here and I'm going to fix it. So this guy's fixed in space, he can't move. And he's mated to all these other pieces, so they're not going to be able to move. They're all going to stay solid. And then this top piece is going to be able to rotate. Okay, but these guys at the bottom won't move. All right? Now, there's different ways to move this thing. In this case, we want what's called a motor movement, because this is a servo motor, and its little shaft right here is going to spin when it's given a signal. So we want to mimic that. They have that here. They have a motor. They also have springs, contacts, gravity, etc. We're going to choose motor this time. You could do a rotary motor or a linear motor, like an actuator, back and forth. In this case, this is a rotary. You need to pick your components. So I'm going to pick this bracket. And if you notice here, it's a little hard to see. It puts this little arrow that kind of shows the direction. And that's what we want. We want it moving like that, in an arc around that arrow. Okay, and then you've got to pick another face to move it in reference to. So I'm going to pick, say, this face down here. So this bracket is going to move as a motor in relation to this face of this component. And it dropped in that component automatically when I selected that face. Okay, and then you get some options. We can do oscillating, and then I was going to do it 60 degrees. Didn't want it to go too far. And you can do it this is at 1 hertz, 1 time per second. You could do it at faster, slower, whatever. Alright, now hopefully this works. I may have to redo this motor. So you see down here, it dropped in the rotary motor movement, and these little keys tell you when it's going to start and stop, and you can drag and move those. So this said it's going to start from the very beginning by moving, which it doesn't have to be. You can drag that out to, say, start later in the movie. And it's going to go to 4.5 seconds. Let's say I want to go to, I don't know, how about 9 seconds? We'll double it. You need to hit this calculate button. That's important. And watch, it's going to go through and calculate the movie. But it didn't do anything. And if I go to hit play, it's going through the movie and it just didn't do anything. And that's because some of these things are mated in here. We've got to get rid of the mates. This guy also went fixed for some reason. We got to make him not fixed. And I don't know why he fixed himself. Well, let's get rid of the mates and hope it works. If it doesn't, I'm going to kill this motor, then get rid of the mates. Alright, so I'm going to show you the mates that are causing the problem. To find these mates, you need to grab your components that you're wanting to move, and you can open them and see their mates. So let's take a look at the mates here. None of these look like they'd be a problem. If you look at these mates, they're over here with this bracket. Those are all okay. That shouldn't cause us a problem. Let's take a look at this component, the servo motor. We'll look at his mates. So right there is going to cause a problem. Do you see those two concentrics? Those are on those screw holes. As those two planes start to move, those concentrics will fail because they're not on the center of the axis of rotation. They're out here. So as we turn, they'll fail. So we need to delete them or suppress them. I'll just suppress those. Actually, I'm going to delete them just for fun. Let's see what else is out there. These are concentrics on those screws at the bottom. Those shouldn't bother us. Okay, nothing there. So we got those. Let's see, what else could we have? You can also select this, and instead of opening it up, you can right click and go to View Mates up here. Those are all okay. I know there's more mates in there that are bad. We've got to find the component that has them. And then if you can't find the component that has them, you can open up all your mates and start checking them out. So all your mates are at the bottom here. That's the global mates. So I'm going to start looking through there because I know there's other ones. None of these should matter on these brackets because they're not interfering with the rotational movement. None of those should matter. Okay, now we're getting somewhere. Now we're getting close. Let's take a look here. A coincident between that face and that face, that shouldn't be a problem. That's going to be a problem right there. Do you see that? That screw is not on the center of the axis of rotation. So if that's mated there, that's going to be an issue. Same here, same here, same here. See 10, that's going to be an issue. 11, 12. I start going into these. These look okay. They're at the bottom of that servo motor. These all look okay. They're at the bottom of that servo. All the way down there. So I bet we're okay now. Let's delete these. Alright. Now let's hope we're lucky. We'll calculate this, and there it goes. Now, notice how it's not operating quite right. You see how it's kind of falling off? It's not really round with that axle, which it should be. That's because we don't have a concentric mate on that axle. So let's make one. So when this thing rotates, we want this circle and this circle to be concentric because they have to be. That axle's spinning it. So let's add a mate. Mate, that circle to that circle, concentric. And that shouldn't mess with the motor turning. Let's recalculate. And there it goes. Alright, and then you can hit play if you want to. We can go into the motor and we can change the frequency. Let's make it say 0.5 hertz. I like the 60 degrees. Okay, but it's only going down, right? What if you wanted to go up too? You'd have to make another motor and do 60 degrees the other direction. So you'd have to change the direction of the face. So you would add another motor and you'd start it. Maybe you want this motor to go from 0 to 4.5 seconds, and then at 4.5 seconds you want it to go up the other way. Okay? And then you can start adding in the motor around this way. And then you can always shift these keys around and it'll start or stop in different places. So I could shift this motor somewhere else. So my whole video is 6 seconds, but my motor doesn't start until 2 seconds in. 1, 2, and now I start moving. Okay? Any questions on animations? So you need to have an animation. I don't care what kind. It could be a functional animation like that. It could be a demonstration animation where you just kind of, do that, zoom in, zoom out, whatever. It can be an exploded view animation. You could zoom in and then you could do an animation on the explode. There's all kinds of things you could do. But want you to be able to do animations for clarity in demonstrations, and you should definitely do that in your senior projects. Yes?
So could you go from the exploded view into an animation?
You should be able to, yes. I may have to sit down and figure that out with you, but you should be able to do that. So you've got this exploded view. You should be able to go in there and animate that exploded view. So you could do like what you're talking about. You should be able to zoom in to this guy, right? And then have it explode. Maybe even turn first and then explode and open up. Yeah, you should be able to do that. I'd have to figure out where that is. So I think you would just go to your exploded view in your configuration manager. You'd animate your explode. You got to get it in here somehow because this is the movie. I'll have to figure that out. That's a cool idea. Remind me, I'll get back to you on that. So we're trying to get an exploded view animation into a motion study. Yeah, that's cool to figure that out. All right, any other questions? Oh, I didn't get to drawing trees. I'll have to do that another day. Okay, I believe the rest of the class is open lab, and I would highly suggest you start writing toolpaths and maybe even machining. There's going to be some bottleneck on the machines, but there's plenty of computers to write toolpaths if you can't get on a machine. And rock and roll. And there's weekend hours, Saturday, Sunday, 10 to 4. So utilize those. Look at the sign-up sheet before you leave, and have a good Memorial Day weekend.